Module 3, first chapter is quantum mechanics. It consists of two chapters, quantum mechanics and nanotechnology. Now the first chapter, quantum mechanics. So before that we have an introduction. Mainly physics is classified into two branches, that is classical mechanics and quantum mechanics. These are the two main branches of physics. So here classical mechanics means it deals with macroscopic particle, because we are dealing with movement of earth, movement of a body, movement of a vehicle, etc. That is we deals with large objects or macroscopic particles, that is classical mechanics. But here quantum mechanics deals with microscopic particle, small objects just like atom, electron, neutron, that kind of ideas come under the category of quantum mechanics. So it deals about microscopic particles. Clear? And in classical mechanics, Newton's laws of motion and laws of gravitation are very important. These are the basics of classical mechanics. In quantum mechanics, what are the basics? De Broglie wavelength, De Broglie hypothesis and uncertainty principle. You may heard about this, De Broglie hypothesis and Heisenberg uncertainty principle. So these are the basics of quantum mechanics. So classical mechanics deals with macroscopic particles, while quantum mechanics deals with microscopic particle. Here the basics are Newton's laws of motion and gravitation. Here the basics are de Broglie hypothesis and uncertainty principle. Now I am going to discuss about the first basics of quantum mechanics, that is de Broglie hypothesis. What about de Broglie hypothesis? It was suggested by the scientist de Broglie. You may heard the concept that light has a dual nature. Light is a particle as well as a wave at the same time. Light can be treated as a wave as well as a particle at the same time. That is the dual nature of light. Okay, so some phenomena require the wave nature of light and other phenomena require the particle nature of light. For example, if you are considering about photoelectric effect and blackbody radiation, here we require the particle nature of the light to describe these phenomena, while in the case of interference and diffraction we require the wave nature of light. So at the same time light can act as a particle as well as a wave. This is known as dual nature of light. So de Broglie suggested that like radiation, like this light wave, particle also possess dual nature. A particle will act as a particle, at the same time it can act as a wave. So it has dual nature, particle nature as well as wave nature. This concept is de Broglie hypothesis. So how can we define this de Broglie hypothesis? Like radiation, particle also possess dual nature. Particle is a particle and at the same time it can be acted as a wave. So wave associated with any particle is called de Broglie wave or matter wave. So according to any particle we can associate a wave. Suppose an electron is moving, which means a wave associated with this electron is moving. A neutron is moving, which means a wave associated with this neutron is moving. All moving particle can be associated with the wave, and this wave is known as de Broglie wave or matter wave. Okay, and its wavelength is known as de Broglie wavelength. So wavelength is given by lambda is equal to h by p. It's very important. Equation for de Broglie wavelength, lambda is equal to h by p, where h is a Planck's constant, value is given, and p is the momentum of the particle, m is the mass and v is the velocity. So p is equal to mass into velocity. So this concept is known as de Broglie hypothesis.